Welcome to SilverTechGuide. I am your host, and today we're analyzing the clinical evolution of digital twin health models and their role in senior independence. Digital twin modeling begins with a simple concept: a virtual replica of your biological systems continuously updated by real-time data. Think of it as a mirror, not of your appearance, but of your internal physiology evolving second by second. This model integrates biometric signals like heart rate variability, glucose response, and circadian rhythm alignment. Clinically, this enables trajectory prediction, the ability to forecast how your health will change over time. Instead of reacting to illness, we begin anticipating deviation before symptoms even appear. This transforms healthcare from reactive treatment into predictive intervention, a fundamental shift in longevity science. For example, subtle disruptions in sleep architecture can signal neurological decline years before diagnosis. The digital twin captures these signals and simulates potential outcomes if patterns continue unchanged. Like a weather forecast, it shows both the current condition and the likely future environment. This empowers seniors to make informed decisions based on future projections, not past data. Heart rate variability, a key autonomic marker, reveals resilience of the cardiovascular system. A declining variability pattern can indicate stress load or arrhythmia risk before symptoms occur. The system flags this trajectory early, allowing clinical guidance without emergency escalation. Metabolic modeling tracks glucose fluctuations to identify insulin resistance progression. Small dietary adjustments can then alter the predicted trajectory, preventing long-term complications. This is known as adaptive modeling, where behavior changes reshape the digital twin in real time. Gait symmetry is another critical biomarker captured through movement analytics. Even subtle asymmetry may indicate musculoskeletal decline or neurological instability. The digital twin simulates fall probability weeks or months in advance. With early intervention, mobility patterns can be corrected before a fall occurs. Importantly, most of this monitoring happens passively, without disrupting daily life. Ambient biometrics collect data through the environment itself, preserving dignity and comfort. This ensures autonomy is maintained while clinical oversight remains constant. The twin is not static. It evolves dynamically as new data refines predictions. Clinicians can test scenarios, such as medication changes, before applying them in real life. This is known as predictive simulation, reducing uncertainty in complex medical decisions. Exercise interventions can be modeled to see how they affect cardiovascular aging curves. Even small increases in activity can shift long-term health trajectories significantly. Respiratory patterns are also analyzed for early signs of decline or disease. Changes in oxygen efficiency can indicate systemic stress or emerging illness. The system may recommend breathing adjustments to stabilize physiological responses. Cognitive modeling focuses on neural efficiency and memory retention patterns. Subtle delays in recall or processing speed can signal early cognitive shifts. The digital twin predicts these changes long before clinical diagnosis is possible. Early awareness allows cognitive exercises to reinforce neural pathways proactively. This concept is known as neuroplasticity optimization, maintaining mental clarity longer. Circadian regulation is another critical component of digital twin modeling. Disruptions in light exposure can affect sleep, mood, and metabolic health. The twin simulates how light patterns influence long-term biological rhythms. Environmental adjustments can then stabilize circadian alignment naturally. The integration of multiple systems creates a holistic health model. This is called multi-armic integration, combining physiological, behavioral, and environmental data. For the user, the experience remains simple and unobtrusive. Complex analytics operate quietly, translating data into actionable insights. Alerts are predictive, not reactive, providing guidance before risk escalates. This reduces anxiety by replacing emergency responses with informed preparation. The core advantage is foresight, understanding where health is heading, not just where it is. This foresight restores confidence in independent living. Stability becomes measurable, not assumed. The twin acts as a silent companion, monitoring continuously. Clinical decisions become collaborative and data-informed. This comparison clarifies the impact of lifestyle adjustments. Small decisions accumulate into meaningful trajectory changes. Over time, these adjustments reshape long-term outcomes. Sleep, movement, nutrition, and cognition all interact within the model. This interconnected view reflects the complexity of human biology. Stress regulation is also monitored through physiological markers. Reduced stress improves overall system stability. The model reflects these improvements in real time. Progress becomes visible, reinforcing positive behavior. Confidence grows when future risks are understood and managed. Preventive action reduces the likelihood of acute events. Life continues naturally without constant medical intrusion. Technology becomes invisible yet highly effective. The model remains continuously active in the background. Each data point refines predictive accuracy. Independence supports social connection and emotional well-being. Emotional health is indirectly supported through stability. Longitudinal data reveals trends across months and years. This long-range view is key to proactive aging strategies. Mobility remains preserved through early intervention. Cognitive function is maintained through awareness and action. Physiological balance supports overall resilience. The system reflects optimal alignment across all systems. Aging becomes a managed process, not an unpredictable decline. Knowledge replaces uncertainty with clarity. Healthcare becomes a partnership guided by data. The technology remains present, yet unobtrusive. Daily life continues with confidence and dignity. The digital twin continues learning and adapting. Each day contributes to a more accurate future model. Stability becomes the goal, not just survival. Rest, movement, and cognition align harmoniously. Predictive modeling is not about extending life artificially, but about aligning biological systems for natural longevity and sustained independence. In essence, a digital twin transforms aging from uncertainty into a measurable, manageable journey guided by continuous, personalized insight. Thank you for trusting SilverTechGuide. Subscribe to join our community of seniors who choose science-backed autonomy.